For Module 4, I'll discuss prokaryotic transcription in this mini video. So here's the diagram I drew. We'll start at the top with our two DNA strands. The top strand is the coding and the bottom is the template strand. In pink, you can see this promoter region. In the promoter region, the RNA polymerase, which is made up of the core enzyme and the sigma factor, binds to here, which will start transcription. The promoter region is made up of this -35 and -10 in this example. These are examples of consensus sequences in which the nucleotides are primarily present in this segment, which shows that they have an important function because it has not changed evolutionarily with the DNA strand. So at the +1, this is the site of transcription where it starts. And after binding, you can see this transcription bubble forming, which allows for initiation and the RNA transcript to begin transcription. The RNA polymerase, after bonding, the sigma dissociates after 9 to 12 nucleotides have joined together in this RNA strand, and after the core enzyme attaches the nucleoside triphosphates, forming this RNA strand. Next is elongation, in which the RNA strand continues to become longer as the RNA polymerase moves to the right on this example, and the nucleotides are added in the 5' to 3' direction on the RNA. Once reaching the termination site, which you can see in blue, this RNA polymerase will unattach and the RNA strand will be created, complementary to this template strand. So we have two different types of termination. The first is Rho independent. In Rho independent, there's an inverted repeated region in the DNA strand, which is transcribed to form a stem loop structure in the RNA. This tells the RNA polymerase to stop transcription, and this template strand has a string of adenines, which allow for the separation between the DNA and the RNA. Next, we have Rho dependent termination, in which the Rho protein attaches to the RNA and moves towards the 3' end and towards the RNA polymerase. Once reaching the termination site, the RNA polymerase will unattach and the DNA and RNA strands will be separated as a result of this Rho protein. Lastly, we have an example of a 5 base pair insertion between the -35 and -10 boxes in the promoter region. With this insertion, this would move the -35 towards the left on this example at the -40 spot. My guess is that it could limit the RNA polymerase from attaching to this promoter region, which would ultimately not allow transcription, or if it could attach and transcribe this protein, the amino acid chain would not code for the right protein because there is this insertion in this area of the DNA strand. And here's my works cited for Module 4.